Hey there, it's Ryan Chan, CEO and founder of UpKeep, and today we're diving deep into the world of pumps, their preventive maintenance, and the crucial role of viscosity in their operation. Stick around if you want to gain a solid understanding of different types of pumps, learn about the importance of regular maintenance, and explore the concept of viscosity and its impact on lubrication. Let's get started. Let's talk about preventive maintenance for pumps. This includes regular inspection for stability and balance, scheduled lubrication, and a thorough evaluation of potential problems. When pumps receive this kind of proper maintenance, they almost never experience a catastrophic failure. Besides a quick visual daily check, most preventive maintenance tasks are done monthly with a few yearly tasks thrown into the mix. So what exactly are pumps? Well, there's a wide variety of pumps available for a multitude of industries and applications. Most pumps fall into two categories: dynamic or positive displacement pumps. Dynamic pumps, also known as centrifugal pumps, use centrifugal force to develop the required pressure. Radial flow pumps only use this force, while mixed flow partially uses this force. Axial flow pumps use a propelling action to create pressure. On the other hand, a positive displacement pump uses an expanding and decreasing cavity to create a consistent flow at set revolutions per minute. They either have a single rotor or multiple rotors. Sadly, pumps are often neglected when it comes to preventive maintenance. To operate at peak efficiency, pumps need to be secure, aligned, and balanced upon installation. In reality, pumps are often placed in precarious locations or misaligned. Plus, regular lubrication is critical to efficient and smooth operation. Even though many companies may choose to replace parts or even pumps instead of maintaining them, this can be a costly decision. Pumps often operate as an integral part of a larger system, putting these other components at risk for failure. Here's a tip. Monthly and annual tasks can be entered into a CMMS, so they are scheduled and performed on time. When maintenance technicians sequence a pump, they should take a quick look at the equipment to make sure it appears to be operating properly. Beyond the visual daily inspection, pumps need only monthly and annual maintenance. Lubrication, packing, alignment, and mounting should be checked every month. Any problem should be resolved immediately for peak performance. Bearings and motor performance should be inspected on an annual basis. Now let's talk about viscosity index. It's a measure of the change of viscosity with temperature. It's arbitrary, unitless, and is generally used to characterize the viscosity temperature behavior of lubricating oils. It's best to use the viscosity index when you need to figure out what lubricant to use in any given piece of machinery that needs lubricating. When creating a preventive maintenance checklist, it's crucial to understand how the viscosity index works to ensure that your machinery is well lubricated. This index measures the change in a lubricant's thickness between 40 degrees Celsius and 100 degrees Celsius. A higher index indicates less variation in thickness over that temperature range. Temperature is a key factor in calculating this index, so knowing the starting temperature of the oil lubricant is essential. Stability in temperature is beneficial because it means the oil lubricant remains consistent. Conversely, significant temperature fluctuations can indicate that the oil lubricant may become unstable and ineffective for its intended applications. So, why is the viscosity index useful when you need lubricant? Simply put, the capacity index gives you a checklist of temperatures that your lubricant needs to be at in order to be effective. This is particularly important in machinery maintenance where lubrication is part of day-to-day life. The viscosity index is used in almost all types of maintenance tasks that require some type of oil lubricant. The correct kind keeps everything running smoothly and properly as it's designed to do. The wrong kind of lubricant or the wrong temperature of lubricant can create an array of failure consequences which ripple out across many different things. You've probably heard of viscosity and viscous fluids before. Examples that come to mind are honey, flavored syrups, and of course, lubricating oil. Kinematic viscosity aims to characterize how thick a certain fluid is. It is defined as a measure of the fluid's internal resistance to flow. Kinematic viscosity is commonly expressed in centistokes, which is equivalent to 1 square millimeter per second. This measure is determined by taking the time it takes a certain volume of fluid to flow through a measured distance. Since fluid viscosities vary with surrounding conditions, kinematic viscosity is reported with the temperature at which it was measured. Dynamic viscosity, also known as absolute viscosity, also describes the resistance of a fluid to flow. It is understandably interchanged kinematic viscosity, though these are very much distinct from each other. One clear difference with kinematic viscosity is the way dynamic viscosity is measured. Dynamic viscosity measures the resistance of a fluid to an external force. This absolute viscosity is expressed in centipoises and is also reported with the temperature at which it was measured. Dynamic viscosity can be related to kinematic viscosity by the fluid's specific gravity. Using centistokes to express kinematic viscosity and centipoises for dynamic viscosity, the following equation can be used. Centistokes equals centipoises divided by specific gravity. Finally, let's talk about how viscosity affects lubrication. Lubrication, such as in bearings, works by forming a protective film between two moving surfaces. Depending on the range and speed of this motion, viscosity affects how this layer of lubricant forms over the material. When checking lubrication on your preventive maintenance schedules, you might want to consider looking into dynamic viscosity. Oil analysis programs use information such as oil viscosity to assess the condition of the oil and of the machine. Remember, oils and lubricants can vary in performance as they are subjected to different working conditions. And that brings us to the end of our deep dive into the world of pumps, preventive maintenance, and the role of viscosity. We've covered the importance of regular maintenance, different types of pumps, and the concept of viscosity. Remember, a well-maintained pump can save you time, money, and a lot of headaches. If you found this video helpful, don't forget to subscribe to our channel for more insightful content. For more information, visit us at upkeep.com. Thanks for watching.